So here's a big question to start us off. What if we could actually build a single intelligent system? Something that could sense, understand, and maybe even help heal our entire planet.
Hmm.
Today, we're doing a deep dive into a really, really ambitious concept. It's called GAIA Core.
That's right.
We're basically going to unpack this speculative blueprint, though it's surprisingly grounded in science for what they call a planetary systems intelligence.
Yeah, it's a huge idea.
Think of this as, well, your shortcut to understanding a massive vision, one designed to tackle humanity's absolute biggest challenges. And just so you know, our insights are coming straight from the source material, GAIA Core, a technical blueprint for planetary systems intelligence.
Exactly. And for you listening, this deep dive is really designed to, cut through the sheer complexity. A vision this big can be overwhelming.
For sure.
We're going to pull out the core ideas, look at the implications, and really help you get your head around this bold blueprint for the future without getting totally lost in the technical jargon.
Great. So let's kick things off with the basic idea, the foundational vision of GAIA Core. It's described as this, well, incredible system, right? Made up of 5 interconnected subsystems.
5 key parts.
And what grabs me is that it's built on tech that's definitely advanced, but crucially, they say it's feasible, stuff we could potentially build. And the aim, solving our most critical global problems.
Absolutely. Those 5 subsystems, they really are the backbone. They each have a very distinct job. You've got the neural quantum mesh, the NQM.
Yeah.
That's basically the planet-wide sensing and computing layer. Think of it as GAIA's nervous system.
Okay.
Then there's the Unified Problem Mapping Engine, UPME. That one's all about modeling global risks, understanding, cause and effect on a planetary scale.
Gripping the ripples.
Exactly. Then the Autonomous Policy Optimizer, or APO. Its job is to advise us, humans, on the best, most ethical actions.
The advisor role, right?
Then the Ecosynthetic Feedback Loop, ESFL. That's for monitoring and actively helping restore Earth's natural systems.
Bringing in the biology.
And finally, the Secure Truth Layer, the STL, a really interesting one, aimed at validating knowledge and fighting misinformation globally.
Wow. That interconnectedness, it really does sound like the key. It's not just 5 separate tools, is it?
No, not at all.
It sounds much more like, I don't know, different organs in a complex body, all working together, communicating, keeping the whole system, the whole planet healthy.
That's a very good analogy, yeah. They have to work in concert.
Okay, let's unpack that first one then. The neural quantum mesh, NQM. The goal is ubiquitous, intelligent infrastructure for real-time sensing, processing, optimizing Earth systems. That just sounds massive. How would that even work?
It is monumental, definitely.
Huh.
The NQM relies on some pretty fascinating features. First, you've got a quantum secure mesh network.
Okay.
Now, this isn't just like, a better internet. Think multi-layered, decentralized,
Yeah.
maybe like blending IPFS for distributing data widely with quantum key distribution, QKD for security.
QKD, right. Using quantum physics for encryption.
Exactly. So you'd have quantum entanglement links, photonic routers, ultra-secure, super fast communication. Then you have the bioneural nodes.
Bioneural, what does that mean?
So these are tiny smart devices embedded pretty much everywhere. Satellites, infrastructure, maybe even smart clothing one day.
Wow.
And they combine neuromorphic chips. Those are chips designed to mimic how our brains work, very efficient with organic computing substrates, so potentially using biological components.
That's kind of mind-bending, combining silicon and biology like that. And how does it handle, damage or changes?
That's the self-repairing architecture. It's actually inspired by things in nature like fungal networks, mycelium, how they spread and heal,
Yeah.
or brain plasticity, how our brains adapt. These nodes aren't fixed. They can actually reconfigure themselves if there's damage or if the environment changes. They adapt like a living network.
That adaptability is. It's just incredible. And here's where it gets really interesting for me, thinking about how it runs, the scalability. Each node runs just a tiny bit of GAIA's thinking, right? Using edge AI.
Precisely. Edge AI.
So there's no giant central brain, no single server farm that runs GAI. It's truly distributed intelligence, no single point of failure.
Exactly. That's a fundamental shift.
What does that mean practically? This idea of a planetary nervous system, how different is that from what we have now?
Oh, it's night and day. It completely redefines distributed systems. Imagine a world where, almost every object is part of this sensing thinking network.
Mhm.
continuously gathering data, processing it locally, adapting.
Right.
It's not just about collecting data anymore. It fundamentally changes our relationship with the planet. We can actually listen to it, respond to its needs in real time, like it's a living entity we're connected to.
Okay, so you've got this NQM, this planetary nervous system, pouring in data. The next piece you mentioned was the Unified Problem Mapping Engine, UPME. This is the part that models global problems, tracks those causal chains, predicts risks. How does it possibly make sense of all that information flooding in?
Yeah, the UPME is really like the Earth's diagnostic center, and maybe it's Foresight Engine too. At its heart is a planetary data lake.
The data lake.
It's constantly drinking in real-time data from all those NQM sensors, satellites, public databases, even things like citizen science projects, people contributing data.
So everything from CO2 levels to, I don't know, crop yields?
Everything, CO2, deforestation, ocean temps, biodiversity metrics, economic data, migration patterns, you name it. All this feeds into a causal graph AI.
Okay, that sounds complex. A causal graph.
Think of it not as just raw data, but as a dynamic map showing connections, how things influence each other. It puts weights on relationships, like showing how strongly carbon output links to ocean acidification, which then links to fishery collapse. It helps you see the knock-on effects.
So you can trace the dominoes falling.
Precisely.
Yeah.
And to really understand the implications, it uses a simulation multiverse.
A simulation multiverse. Sounds like something out of sci-fi.
Kind of does. But the idea is using serious computing power, maybe quantum computers eventually, along with probabilistic AI, to run millions of what-if scenarios, millions of possible futures based on different actions or policies.
So you could test drive a global policy before implementing it.
Exactly. Imagine testing a new global water treaty across thousands of different climate and economic scenarios simultaneously to see the likely long-term impacts.
Wow. Okay, so what's the output for us then? How do we interact with this diagnostic brain?
Well, the output is visualized as something like a continuously updated dashboard, showing planetary risks, making predictions, even highlighting potential ethical dilemmas raised by the data or the simulations.
A planetary health monitor in real time.
Pretty much.
Mhm.
For forecasts. But the real power isn't just seeing the problems, it's understanding those hidden, complex connections between problems. So we can hopefully tackle root causes, not just, react to symptoms all the time.
Which leads us nicely to the next piece, the Autonomous Policy Optimizer, APO.
This is the system designed to help governments, communities, even individuals make,
Hmm.
what was the phrase? Ethically aligned, mathematically optimal decisions.
That's the goal.
Now, whenever you hear AI and optimal decisions, especially about policy, people immediately worry about control, don't they?
Absolutely. It's the natural question.
Does this thing, does it tell us what to do? Does it take over?
That's a critical point, and the blueprint is very clear on this. The APO acts as an advisor, not a dictator. It has a multi-objective optimizer.
Okay.
It weighs different goals: economic health, environmental sustainability, social equity, ethical considerations, all at the same time. It uses concepts like Pareto frontiers to find those solutions where you can't improve one thing without making something else worse, finding the best possible trade-offs.
So it shows you the options and the compromises.
Exactly. And crucially, it has a value alignment core. This is designed to learn and align with human values.
How does it do that?
Values are complex and diverse.
They are. It uses advanced techniques. Things like constitutional AI, where the AI has a built-in set of core principles, like a constitution it can't violate. Also, inverse reinforcement learning, where it learns what we value by observing human choices and feedback in debate models, where different AIs argue positions to find robust solutions.
Okay, so it learns our values. Then what? How does it present its advice?
Through civic interfaces. These could be open online forums, maybe immersive VR simulations where you can experience the potential outcome of policy, or dedicated civic AI platforms.
And the safeguard.
The absolute critical safeguard is humans always remain in control. The APO makes recommendations, provides data, shows simulations, but it cannot implement anything on its own. Humans decide.
So no robot overlords.
No. Plus, there are hard-coded moral constraints. Like, it physically cannot suggest policies involving violence or coercion, and any significant proposal can be simulated, debated, and voted on by humans before anything happens.
That emphasis on human oversight, on ethical guidance rather than control, that seems really fundamental here. It's about getting the best advice, backed by incredible data, but not handing over the reins.
That's the core principle.
But even just advice from a super intelligent planetary AI, couldn't that subtly steer us in ways we don't intend? Does the blueprint talk about that kind of softer influence and aligning with all human values? That sounds like maybe the hardest part.
That's a really sharp point. Yes, influence is definitely a spectrum. The main guardrail against unintended steering is meant to be radical transparency.
Seeing its work.
Exactly. The APO's proposals would come with all the data, the models, the trade-off calculations, the ethical reasoning laid bare. The idea is to empower human judgment with information, not manipulate it.
And the diverse values.
That's probably the Mount Everest of challenges here. The system is designed for democratic coevolution, meaning it learns and adapts continuously through ongoing global dialogue, feedback, referenda. It's meant to reflect an evolving human consensus, not impose a static set of values decided by a few engineers. It's a living ethical framework.
Okay, that makes sense. A continuous dialogue. Let's shift gears a bit to the ecosynthetic feedback loop, the ESFL.
Ah, yes, the ESFL.
This is that biodigital layer for maintaining Earth's ecological balance. It sounds fascinating, mixing biology and tech directly in the environment. How does that work for, say, restoring ecosystems?
It's a really innovative part of the concept, yeah.
Yeah.
The ESFL integrates some pretty amazing technologies, for instance, DNA-based programmable organisms.
Programmable organisms,
Those,
like
yeah.
custom microbes.
Exactly. Microbes engineered for specific jobs, maybe sequestering CO2 from the air, cleaning pollutants from water, helping restore nutrients to depleted soils,
Yeah.
using biology's own tools. Then you have things like nanobot swarms, tiny robots deployed perhaps in oceans or cities to constantly monitor pollution, maybe even break down microplastics or neutralize toxins at the source.
Nanobots cleaning the ocean. Okay.
And there's also biotic AI symbiosis. This involves embedding tiny sensors directly into living things, trees, coral reefs, maybe even tracking animals that communicate directly with GAIA Core.
So the planet's biology is feeding data back constantly.
Continuous biofeedback, yes, giving a real-time picture of ecosystem health. So you could use the ESFL for things like tracking forest health with incredible detail, managing smart green infrastructure in cities that adjust to local conditions, or even potentially helping with pandemic response by distributing treatments or vaccines biosynthetically.
It's almost like giving the Earth its own active immune system, guided by this intelligence, reaching from huge forests down to microbes.
That's a great way to put it, leveraging biology and nanotech guided by AI to actively heal and maintain planetary health from within.
Okay, now for something incredibly relevant today. The Secure Truth Layer, STL.
A big one.
Aiming to restore trust in information, science, reality itself. That is a massively bold claim in our current world. How on earth could it tackle something as slippery as misinformation?
It is incredibly bold, but the proposed mechanisms are quite interesting. At its core is something called an epistemic ledger.
Epistemic ledger, like blockchain.
Similar principle, yeah. Using decentralized ledger technology, DLT. Every knowledge claim, a scientific finding, a news report, a data set gets time-stamped, source traced, and references its evidence and peer review on this immutable ledger.
So you can track any piece of information back to its origin and validation?
That's the idea, a transparent, verifiable history for information. Then there's decentralized fact validation. This isn't one central ministry of truth.
Right.
It uses a combination of public checks, expert review panels, and AI consensus mechanisms to continuously validate data and claims in real time, a distributed network checking things.
Okay, distributed trust. What about for the average person? How does it help me figure out what's true?
That's where the personalized knowledge graphs come in. For each user, the STL could generate a kind of contextual map of truth based on their questions and background. It wouldn't just say, this is true, this is false.
What would it do?
It would show you how different pieces of information connect, what the supporting evidence is, where the consensus lies, maybe where there's debate or uncertainty. It's about providing context and pathways to understanding, not just labels.
That sounds like a much more powerful approach. Providing context, not just verdicts. And the source mentions specific anti-misinformation tools, like AI counterfactuals.
Yes, some really interesting tools. AI could generate counterfactuals, basically showing you, okay, if this false claim were true, here's what else would have to be true, and we know that's not the case.
Showing the logical inconsistencies.
Exactly. Plus, real-time deepfake detection becoming much more robust, and potentially even dynamic trust scores for media outlets or even individuals based on their track record of accuracy and verification.
Trust scores. That's where it gets really interesting, maybe a bit controversial too, for how we consume news and interact online. How might that change things day to day?
It could fundamentally change the information landscape. Imagine reading an article, and your browser or device, plugged into the STL, instantly shows you its verifiable source chain, flags potential manipulations, cross-references claims against the global knowledge base.
Like having a built-in fact checker and context engine for everything.
Sort of, yeah. The trust scores would be dynamic, reflecting ongoing behavior. It's an attempt to build resilience into the information ecosystem, not just playing whack-a-mole with falsehoods, but empowering everyone with better tools to navigate information and hopefully rebuild some shared understanding of reality. Now, obviously, a system with this kind of potential power needs incredibly robust ethical governance. You can't just build it and hope for the best.
Absolutely. What are the principles guiding it?
The blueprint stresses a few core ideas. First, transparency. Everything, the code, the data inputs, the policy algorithms, the decision reasoning, is meant to be radically open source and auditable by anyone. No black boxes.
You can source everything. Okay.
Second, democratic coevolution. GAIA Core isn't static. It's designed to evolve based on global human input referenda, participatory design workshops, ongoing debate. Humans collectively shapes its development and its values over time.
So it learns and changes with us.
Yes. And third, something quite unique, rights for nature.
Rights for nature. What does that mean in this context?
It means the system explicitly includes non-human stakeholders in its models and ethical calculations. The well-being of ecosystems, biodiversity, animal populations, these are factored in as important goals alongside human needs, not just treated as resources.
That's a profound shift in perspective, including the planet itself as a stakeholder.
It is. It reflects the GAIA name, treating the Earth system holistically.
Empowering all this. I mean, the energy requirements must be astronomical, and the hardware.
Yeah, the infrastructure is equally ambitious. They envision distributed renewables like solar everywhere, orbital solar power stations beaming energy down, maybe even fusion reactors eventually.
Next level energy.
And the hardware itself is designed with sustainability in mind. Things like biodegradable processors, maybe using those organic computing substrates we talked about. All secured, of course, with quantum encryption and sophisticated AI constantly watching for anomalies or threats.
It's a complete long-term vision, but building that kind of planetary infrastructure, coordinating that across countries, that seems like maybe the biggest hurdle of all.
Oh, undoubtedly.
Yeah.
The geopolitical coordination, the resource mobilization, it's immense. It's as much a social and political challenge as a technological one.
So how do they propose getting there? You can't just flip a switch on GAIA Core.
No, definitely not. The blueprint outlines a phased deployment roadmap. It's a gradual process over decades.
Okay, what are the phases?
Phase 1, they call foundation, maybe 2025 to 2030. That's about building trust, setting open data standards, getting initial regional mesh network nodes up and running, laying the groundwork.
Building the base layer.
Exactly. Phase 2, integration, maybe 2030 to 2035. This is where you start linking major systems, environmental monitoring, public health data, economic models, educational networks into the core system, connecting the dots.
Okay, starting to bring it together.
Then phase 3, optimization, say 2035 to 2040. Now the system gets sophisticated enough for real-time policy simulation and testing, serious global modeling, and enabling that ethical co-governance we discussed, refining the system's capabilities.
Getting smarter.
And then finally, phase 4, planetary autonomy, perhaps 2040 onwards. This is the long-term vision where GAIA Core, having learned and been guided by humanity for decades, can help maintain planetary balance more autonomously, requiring less direct human intervention for routine optimization, achieving a kind of sustainable, self-regulating state.
Planetary autonomy, that's quite the end goal. That phased approach, though, it makes it seem less like science fiction and more like a very, very long-term engineering and societal project.
Precisely. It acknowledges the immense scale and the need for gradual development and adaptation.
So wrapping up, we've journeyed through this incredible concept, GAIA Core. From its planetary senses in the NQM to its problem-solving brain in the UPME, its ethical advisor, the APO, its healing touch with the ESFL, and its truth-seeking layer in the STL. It's just an amazing scope, blending these advanced technologies, quantum computing, AI, biotech, nanotech, but framing them as, well, potentially feasible steps.
Yeah, this deep dive really just scratches the surface, but hopefully it gives you a real sense of this potential future. A future where technology isn't just fixing isolated problems, but is designed from the ground up to understand and manage our planet's well-being holistically, like a truly integrated, responsive, living system.
It really does. And it leaves me with a final thought, maybe for you listening to, if, and it's a big if, but if a system like GAIA Core could actually work, if it could genuinely help us optimize planetary health, maybe free us from battling constant existential crises like climate change or pandemics, what then? What new questions would we as a species finally have the freedom to ask about ourselves, about our purpose, our future? What grand challenges could we tackle once the basic health of our home is secured?